There are a lot of metadata schemas out there to choose from, and several that are unique to specific disciplines. Today, I'm going to share what I've learned about the Ecological Metadata Language Specification, commonly abbreviated to EML. So why was EML created? The EML information is provided by the Knowledge Network for Biocomplexity. According to their website, the KNB is an international repository intended to facilitate ecological and environmental research. The KNB links EML as their preferred metadata schema on their website. So what is EML? It is a metadata specification developed by the ecology discipline and for the ecology discipline. It is based on prior work done by the Ecological Society of America and associated efforts. According to EML's purpose statement, it exists to provide the ecological community with an extensible, flexible metadata standard for use in data analysis and archiving that will allow automated machine processing, searching, and retrieval. The KNB website also makes it clear that EML is largely designed to describe digital resources. However, in rare cases, it can also be used to describe non-digital resources. Here are some quick facts to keep in mind about EML. EML is encoded in XML and is an open source project. There are several ways provided on the EML website for interested parties to participate in the development of the schema. EML uses syntax from several other metadata schemas in an attempt to ease adoption and document conversion. Some of the schemas which influenced EML include Dublin Core, Geography Markup Language, and the Scientific, Technical, and Medical Markup Language, among many others described in the EML documentation. One of the ways that EML is unique from other metadata schemas that we've looked at so far is that it is based on modules rather than a static list of elements. Let's dig into what this means. EML modules exist in a hierarchy that is broken down into chunks of functionality which are nested within each other. The structure is somewhat similar to what we've seen in schema.org, but submodules are often able to be used by more than one top-level module. Each module has a set of elements, types, and attributes. There is a root element in the EML schema spec, unoriginally named EML. There are 4 top-level modules, at least one of which is required to be present in the EML tag. These are dataset, citation, software, or protocol. Optional tags include access and additional metadata. The latter is a repeatable element that can catch other specific metadata information which might not fit in one of the 4 required elements. Here is a graphical representation of the data model for elements within the EML tag. As you can see, the dotted lines here represent optional elements, and the solid lines represent modules, one of which must be present in the root element. As we drill down into the top-level elements, we see similar data structures for each one, with submodules that follow a chain up into the top-level element. And these modules can get very specific very quickly. For example, this is the representation of the data model for the software module, seen here, one of the top-level modules. And as you can see, this architecture diagram is far more involved. Each module has different elements that can roll up under it, but there is one set of elements used by all modules, and that is the EML resource module. This module contains several of the common metadata elements such as creator, title, pub date, and description. Many of these tags carry over from other schemas that we've seen, such as Dublin Core. It is not a standalone schema, and it is present in all other modules. While the 4 top-level modules and the EML resource module are fairly general and occur throughout the data, there are several modules specific to the ecology discipline, such as the EML methods module, and some of the elements found within that one are sampling, study extent, methods, instrumentation, or the EML physical set, which is describing the physical documents used to capture the research. So this is the size in bytes, the encoding method used in the files themselves, number of header lines for tables, etc. There are some sample data sets linked on the KNB website, which provide examples of how other users have annotated their data using EML. So I'm going to share one of those here. This particular data set is provided on the KNB website. And you can see as we scroll down, this is about plankton in Lake Baikal in Russia. And we can see some of the associated metadata as we scroll down. We can see some of the dataset creators and their contact information, as well as geographic region information. There's even a map. So if we look at this information in EML, for example, we can see, so this is an EML file. We're able to see this root EML tag, so we can see that it's valid EML, and it has one of the required top-level modules, which is dataset. As we drill down into the dataset, we can see some sort of familiar-looking examples of XML-encoded metadata. So we can see the title of this dataset, some of the organizations responsible for its creation, the National Center for Ecological Analysis, some of the individuals who've contributed to this dataset. So this fellow and his contact information, as well as the publication date of the dataset. We can also see, if we shrink this element, some of the additional metadata fields associated with it. So there's number per liter, so notionally number of plankton found per liter, or this one is time information, or micrograms per liter. So we can see it follows a lot of this similar format that we've seen in other schemas that we've seen. So one of EML's strengths is its extensive documentation, which we can see in this tab here. There's a lot of documentation, and it is very thorough. It is both detailed on a narrative level as well as a technical level, which is very helpful. It would take quite a bit of time to master all of the information that is presented here. One of the other nice things about EML is that it includes a parser, so users who are using EML for individual ecological projects are able to upload their own data into the EML parser, and it will verify whether your EML is correct or not, which is a really handy feature. Another one of the sources used in EML or by practitioners who want to use EML is Morpho. That is software linked from the KNB website. It is allowing the user to enter their own data, and it generates the EML for them, so they don't have to deal with parsing it themselves. It also allows the user to query and reference other public ecological data sets. There's also a bug tracker page and an FAQ page where users are able to submit issues that they find with the schema. And to wrap up, EML represents a really powerful set of functionality and is especially useful due to the amount of supporting documentation, tooling, and the active community contributing to it. While the module structure presents a bit of a learning curve compared to some of the schemas that we've already looked at, it's straightforward enough once the user is able to wrap their mind around its structure. In the bibliography attached to this assignment, I include several links that I consulted in preparation for this presentation, and would welcome any questions in the comments section of the assignment. Thank you.